answer now. I know you'll be familiar with some standard derivatives like y is equals to in x, then dy dx is equals to 1 over x. In this lesson, we're going to prove this standard derivative. If y is equals to ln x, y dx is equals to 1 over x. Now, first I want us to remember from our first principle that when y is equals to f of x, my dy dx is the same thing as, we'll take the limit. Here is f of x plus h minus f of x all over h as h tends to 0. So I want you to remember that e is given as 1 plus 1 over n raised to power n, taking the limit as n tends to infinity. Now, with these two basics, we'll keep this because they are basic assumptions that we'll use in the course of this proof. Now, we've said that our y now is the same thing as ln x, that is which is equal to my f of x. My dy dx is the same thing as ln x plus h minus ln x over h, taking limit as h now tends to 0. Remember from basic logarithm that the log of a minus the log of b is the same thing as the log of a over b. So that we're saying that my dy dx is the same thing as the limit as h tends to 0, I have the ln of x plus h all over x, everything here over h. Now, this is the same thing as the limit as h tends to 0, we have ln of x here will be over x plus h over x all over h. All I've done is I've splitted this cumbersome expression so that x here is 1, x here is 1. So that here I should have 1. So that I can now rewrite that as dy dx be the same thing as, we're taking limit as h tends to 0 of ln x over x plus h over x all over h. Now that means my dy dx, I want to rewrite this as, here I have h. H here is the same thing as multiplying this whole expression with 1 over h. See it this way. That is limit as h tends to 0, I'll pick 1 over h, then x over x is 1 plus h over x. Now remember again from logarithm that if I have a log b, I can easily write this as log b raised to the power of a. So I'll rewrite my dy dx in this form. I'm taking limit as h tends to 0 of ln 1 plus h over x, everything will be raised to power 1 over h. Now let's make some substitution. I want to substitute h over x to be equals to m. So that if I'm substituting h over m to be equals to m, it implies that my h is equals to mx. Now from this relationship, if you look at h and you look at m, you see there's a direct proportionality. So that as h is going to tend to 0, m also will tend to 0. Now my dy dx can simply be rewritten as, dy dx can be rewritten as, I've taken limit, remember we're substituting for h, and as h is tending to 0, m also is tending to what? 0. Then this is the ln of 1 plus h over x, we say is equals to m, and 1 over h now will be the same thing as 1 over mx. Now m and x are multiplying each other, so I want to rewrite this as the limit as m tends to 0, the ln of 1 plus m into 1 over m times 1 over x. Now I want us to still apply the same principle we apply here to split this simple multiplication, so that the y dx again is still the same thing as, I want to bring 1 over x now back here because I'm actually driving towards something. This will be 1 over x limit as m tends to 0. I have the ln of 1 plus m raised to power 1 over m. Now, if you look closely, you see that we're beginning to look like our basic assumption here. This is 1 over n, and this is n out here. So we want to make another substitution and see how it's going to work. Now, let's make another substitution. My m now, I want it to be equals to 1 over n. If m is equals to 1 over m, you see the relationship here is inverse proportionality. That as 1 is equals to 1 over m is equals to 1 over n, obviously n also is equals to 1 over m. And as m tends to 0, n is going to tend to infinity. So that my dy dx in this case will now become 1 over x. We take limit. Now it becomes n now is tending to what? Infinity. The ln of 1 plus 1 over n, m is equals to 1 over n, remember? And 1 over m is equals to n. Obviously, what we have here, 1 plus 1 over n, is beginning to look closely like the value of e. So in place of 1 plus 1 over n, I'm going to substitute for e. So that my dy dx will be the same thing as 1 over x ln or limit as n tends to infinity ln e. Now you should know where we are driving to. Ln e is the same thing as 1, because this is the same thing as saying log e base e. So everything here should drive to 1. Let's open another slide. Now, confidently, I can now say that dy dx is the same thing as 1 over x, the limit as n tends to infinity in ln e. Obviously, ln e is the same thing as log e base e. So everything here tends to what? 1. So that this is equals to 1 over x. dy dx equals 1 over x.